In this PowerPoint, we are going to learn about nomenclature of cycloalkanes and bicyclics. So all the rules that you have for aliphatic hydrocarbons, they are still applicable with a slight twist. So the rings will have CH2s all around, whether it's a ring of 3, 4, 5. In some cases, it's not CH2s, it's CHs, depending on the substituents, but usually it's CH2. The formula for all the cycloalkanes is CnH2n in general, and that is without any substituent. CnH2n means that it's kind of similar to alkene, so it's missing 2 hydrogens. Cycloalkane usually is going to be your base compound when you start the nomenclature. There will be some exceptions, and we'll talk about that when we get there. So if you have just the one substituent and you don't need to number anything, but if there's going to be more than one substituent, then you are going to have to number the carbons. Okay, so we'll talk about that also in the following slide. So then how do you number things? The numbering is slightly different from straight chain. In the straight chain, you start from closest to the end. But in this case, because you're talking about a ring, the numbering is actually alphabetical rather than from one point or another point. Okay, so alphabetical is the way you go. You can see that that does not happen when you are in the straight chains. Okay, in the straight chain is according to the branching and closest to the terminal atom. Slightly different. When you have a long chain that is attached to a small ring, then the long chain gets the preference, okay, for nomenclature. What does that mean? That is going to be your base name. So your base name is either going to be the ring or your base name is going to be the substituent. So what is the base name? So that depends on the number of carbons, okay, and sometimes it also depends on the ease of naming something. All right, so we'll talk about that with the examples. So first of all, let's just look at some of the very basic cycloalkanes that we have. So cyclopropane, cyclobutane, cyclopentane, cyclohexane. You can have cycloheptane also in all of those cycloalkanes. So these are your very fundamental rings. Let's talk about nomenclature. So keeping it very simple, if you look at the first one, there is only one substituent over here, and this substituent is the isopropyl. The base ring is going to be the cyclopentane, so the name is isopropyl cyclopentane. Now if you rotate the ring, the cyclopropane will also rotate with it. Really, there is no point in saying one isopropyl cyclopentane. So you don't have to number anything. If there is only one substituent, you don't have to number anything. The next example that we have is where you have the cyclohexane as your base name. So that's cyclohexane. And then you have two substituents over here. One is a methyl group and the other one is a T-butyl group. The T-butyl group, remember the alphabet starts from B and not the T. So the butyl group then gets the preference, okay, because that is alphabetically lower. So which means that for you, your numbering is going to begin from the T-butyl group. Okay, so that's how your numbering is going to be. So 1, 2, 3, and then 4. Okay, so that is how you will do the numbering. And as I said, your alphabetical substituent will determine your numbering also. Okay, so you keep chronological and alphabetical together. Okay, that's possible in cycloalkane. So that's what this is. So 1-T-butyl, 4-methyl cyclohexane. Don't forget your dashes. Okay, those are still valid. Okay, between alphabet and numbers. Let's look at C over here, and in case of C, you have 3 substituents. So where do you start the numbering? Your numbering is going to start at the ethyl group because ethyl is alphabetically lower. Once you have decided that this is the alphabetically lower, now you just have to make sure you number in such a way that all the substituents get a lower number. So 1, 2, 3, 4, 5, 6, right? Those are your 6 carbons. So 1, 2, 3, 4, 5. That's going to be your numbering, okay, rather than the other way around, because if you do it the other way around, then the methyl groups will have a higher number, and that is wrong. Okay, so then your name becomes then for this compound 1-ethyl 2,5-dimethyl cyclohexane. Again, remember the commas and remember the dashes and the dimethyl, okay, for the two methyl groups. This is an awkward looking thing. Number D is awkward, but your base name here is cyclopropane. On the one carbon, you have two groups coming out. And so because you have two groups coming out of the same carbon, you have to mention that numbering. Okay, so one ethyl and then one methyl. Again, alphabetical, okay, ethyl and then methyl. But you have to put the number, the locant, so that you know where to put those ethyl and methyl groups. Okay, so 1, 1. That's how it goes for number D. For E, it's a little bit an awkward thing because now in this case, you have a long chain going on and then you have the cyclopentane over here. So this is where you will change the rules, okay? And the changing of the rules has to do with the number of carbons you have in a chain. So in this cyclopentane, you have 5 carbons. And in the long chain, you have 1, 2, 3, 4, 5, 6, 7 carbons. So the 7 carbons more than 5, so 7 takes precedence. So 7, which is heptane, then gets the base name, and the cyclopentane then becomes cyclopentyl group. Okay, and now you have to follow the rules of the aliphatic nomenclature, which is that your numbering will be closest to the terminal. So your branching is going to be closest to the terminal. So you have lower numbers for your substituents. So your substituent here is cyclopentyl group. It's on the second carbon. So 2-cyclopentyl heptane. Now, one other thing that happens in case of cycloalkanes is the cis trans isomerism. And the cis trans isomers, remember again, it's the structures that are different but the same molecular formula. Okay. And so the cis trans has to do with the location of the groups that you have. So, and the groups that we're talking about here are going to be the hydrogens. Okay. And so in this case, in the first case, the hydrogens are on the same side. So if they're on the same side, it's called cis. If the hydrogens are on the opposite side, this is called trans. Remember, the cis and trans have to do with where the hydrogens are. So if there are no two hydrogens, you cannot use cis and trans. Okay, you can use it loosely, but not really accurately. Okay, so cis and trans have to do when you have two hydrogens on the same side or on the opposite side. So why do we have this problem in case of cyclic compounds? We have this problem because in cyclic compounds, you cannot rotate the ring. Okay, I mean, you can rotate the ring like this, but you cannot twist the bonds. You cannot rotate the bonds in there because it's in a ring. So if you twist the ring to rotate any bond, as we say that single bonds can be rotated. So if you do that, you're going to break the ring. So which means that whatever is in particular location, it is actually stuck there. And so because it is stuck there, you have to be able to tell by nomenclature as to where that fixed position is. Okay, so in the first case where you have two methyl groups, the two methyl groups are going in the same direction and the two hydrogens are in the same direction. By the way, we talk about the same and going in opposite directions very simply by using these wedges and dash lines. The dash line means that there's something is going behind, and wedges means something is coming in front of the plane of the paper, right? So here in this case, the hydrogens are in the same place. So if they're same, then that's going to be cis. If they're in opposite, then it's going to be trans. Okay, so you can see here that one hydrogen is going behind, the other hydrogen is coming to the front. So if you want to show a 3D depiction, then that is how you would draw it out. Okay, so if I give you a structure with cis and trans on it, the best way to show cis and trans is by using these wedges and the dash lines. Okay, so you have a cis and trans. So now how do you show the cis and trans? So for example, if you look at the examples above, like in this one, you were not given the option for cis and trans because you don't know the T-butyl and the methyl group. What is the position of these. Are they going behind the plane or are they going in front of the plane? You don't know. So if you don't know, you don't have to mention it, okay? But if it is given to you in a three-dimensional way, then you have to indicate it, okay? So you have to write it in the name as in cis and trans. Now in typed form, we write it like in italics, but if it's not possible for us to do it like when we're writing, then you just use brackets, okay? And so then you write cis and trans like that. So that is how you deal with lack of rotation in cyclic compounds. So you end up having cis and trans isomerism. This is also called geometric isomerism. Now for the bicyclic compounds. Bicyclic compounds are where you have two rings that are fused together, not connected by a bond. Okay, so what does that mean? That something is actually fused together. Let me show you the connected together first. Okay, so you understand what that means. So here I have two cyclopentanes, and these two are connected with the bond. Now, if I were to take that cyclopentane and actually fuse them together, this is what they would look like, which means what they're doing is they're actually sharing two carbons, okay, in the middle over there. So this is called fusion, where two rings are sharing two carbons, okay, together. Okay, so in bicyclic compounds, you actually have fusion going on rather than that single bond connecting. So when you name the bicyclic compounds, the first of all, the thing is to identify that you have a bicyclic compound. So bicyclics will generally stand out, and you will see that there are two rings in there. And so one ring and then the second ring, okay, in there. So that shows you that you have two rings. So you know it's a bicyclic compound. So how do you start with the naming? So first of all, what you do is you write the bicyclo, okay, because you know it says bicyclic compound. So you write the bicyclo, you put square brackets, and we'll talk about these numbers in a second. And then the heptane. Where is the heptane coming from? Heptane is the total number of carbons you have in there. Okay, so the total number of carbons would be then 1, 2, 3, 4, 5, 6, 7. So the total number of carbons is 7 carbons in this case, so that is heptane. So that is how you get the bicyclo and the heptane. Now let's talk about the middle part, which is the numbers that you have in the square brackets. So first of all, you have to identify two different kinds of carbons that you have in a bicyclic compound. So one type of carbon you have is what's called the bridgehead carbon. The bridgehead carbons are going to be these corners, and these corners, they have 3 bonds coming out of it. So if you see 3 bonds coming out of any carbon, that means it's going to be a bridgehead carbon. So here, 3 bonds coming out of it. That's a bridgehead carbon. So usually in bicyclic compounds, you're going to have 2 bridgehead carbons. The other carbons that you have now in there, these ones, and this one, these are called bridging carbons. So it's almost like going from point A to point B. Okay, so going from point A to point B, and you have 3 ways to get there. Okay, so that is the bridges that you have. So those carbons that are in that bridge, those are called the bridging carbons then. Okay, so you have 2 things already. You have the bicyclo in your name, and you have the heptane, which is the total number of carbons. Now what you have to do is you say, okay, I have this bridgehead and I have this bridgehead. Now what I need is these numbers. How many carbons are connecting these bridgeheads? So 1, 2. 1, 2, and these in the middle, this is just 1 carbon that is connecting. So 2, 2, 1. Okay, so 2, 2, 1. Those are the bridging carbons that are connecting the 2 bridgeheads. So that is how you number these things, and that's how you get the numbers in here. So in some cases you will have substituents. We'll talk about that in a second, but if you have no substituent, this is your base name. Okay, this is the basic. Now I want to talk just about one small thing over here, okay, before I move on. This structure that you see here, this is a 2-dimensional structure. Okay, so this is something that you draw and you're comfortable with. It's easy to see, but generally in a 3-dimensional structure, this is what you will see. Okay, is you have these rings as bent, and they're actually going out of the plane and whatnot. Okay, so we draw bicyclic structures in very different ways. Okay, so this is not the only way, and this is also not exactly the correct way, okay, of drawing structures. It doesn't matter, you know, we do what we can. Okay, so that is how you do the basic nomenclature. Now, if you have substituents, okay, in your ring, then you have to number all the rings. So, for example, in this case, okay, you have numbered all the carbons. So there are two rules for this. Number one, you will always start from the bridgehead carbon. So you can see that over here also. Okay, so you will always start from the bridgehead carbon. So whether you started from 1 or 5, it did not matter. You have to start from a bridgehead carbon. The second rule is you always have to number the large ring first. So which means that the side that has more bridging carbons is where you have to go. So in this case, the 2, 3, 4 that you see here, this is the larger number of a bridge than 7 and 6. Okay, and that is why you have to go there, which means your substituent may not necessarily have the lowest number, and that's fine. Okay, so that's totally fine in bicyclic compounds because the rules are a little bit different. Okay, I do give you some substituents sometimes in bicyclic compounds, so try to remember these rules. It's not all that difficult, I think. Okay, so let's do some examples now. All right, and we'll do this quickly because I think you know all the rules now. So we just have to go ahead and write the names of all these compounds. So the first one is pretty easy because this one is going to be the methyl group, of course. So methyl cyclo pentane. Okay, so the cyclic ring here is the 5-membered ring. In the second one, of course, we have a cyclohexane. Now it's up to you how you want to do this. I like to go ahead and write my substituents, so methyl, ethyl, and then I write my base name first, so which means cyclohexane. You will please remember to write the cyclo. You won't believe how many times I don't see the cyclo in the name. Okay, so make sure you don't forget to write the cyclo. Now, how I do in the numbering in this case, I have to start from the ethyl because that's alphabetically lower. So that's 1 ethyl, 2 methyl cyclohexane. Okay, so that's how this one goes. In the third one, I have a methyl group, and then this is isopropyl. Isopropyl is alphabetically lower than the methyl group, so I will start my numbering from isopropyl 1, 2, and then 3, not the other way around. Okay, otherwise the methyl group will have a higher number, so I don't want that. My base name is cis cyclohexane. Now I have one other thing in here, and I'm sure you will see that too. Let me go ahead and write the 1 isopropyl 3 methyl. I'm running out of room. And the one thing that you noticed probably also is that I have given the little bit of the geometric isomerism over here. So this is one group going back and one group coming to the front. So that's the methyl group. So what I am to presume from here is that the hydrogen here is going to the back and the hydrogen here is coming out. So I don't have to draw the hydrogens in order to know the cis and trans because I know hydrogens are there. They're just invisible, okay? So, but I have to now write trans over here, so that will give me the full name, okay, for this compound. So I look for cis and trans also. Wherever possible, you give that as well. Okay, let's move on to the next one. So now we have a cyclopentane. And I have methyl, and then ethyl. So in this case, my numbering is going to start from the ethyl group. So 1, and I think 1, 2, 1, 2, 3, 4. Whether I do this or 1, 2, 3, 4, I get the same numbers, okay, either way. So it doesn't really matter where I number from, because in both cases, yeah, it's the same. So it means that I have 1 ethyl and then 3, 4 dimethyl cyclopentane. Now in this case, I'm also given the wedges over here, but because I have 3 groups, I really cannot do the cis and trans over here. Okay, so in this case, even if I'm given something, I cannot do it, because cis and trans is actually a relationship between 2 groups, and in here I have 3 groups. Okay, so even though I don't know whether the third group is going in the front or the back, I really cannot say anything, okay, about cis and trans. So I just wanted to mention to you that don't get fooled, okay, by that little thing. Okay, so the next structure then that we have is 2 rings, okay, over here. So these are 2 cyclohexane rings which are connected by 2 carbons over here. So this is a weird one, because now the straight chain actually is 2 carbons, which is way less than 6 carbons in a ring. But my nomenclature would be so much simpler if my base name is ethane. Okay, so I'm going to go with that, all right, because otherwise it's going to become really hard for me to name my structure. Okay, so my base name here is going to be ethane. So my numbering is going to be the 1, 2 that I have, and I have 1, 2 dicyclohexyl. So here I'm using my cyclohexane as substituents. Okay, so that's why I'm ending in -il over here. So this is just because of ease. Otherwise, IUPAC dictates that the larger ring should be the base name. Okay, so you're most welcome to go ahead and make your life a little bit easy, okay, when you get structures like this. The next structure we have is a bicyclic compounds, and you can see that because it's looking a little bit weird. So the first thing that I will do, of course, is I'll go ahead and write bicyclo, because I know it's bicyclo. Then I will put my brackets on there, and then I'll count the total number of carbons that I have. So starting from bridgehead, and that's this 1, 2, 3, 4, 5, 6, 7, 8. So which means it is an octane. Okay, and then what I have to do is I have to identify my bridging carbons. So my bridgehead carbons are 1 and 5. Okay, 1 and 5 are my bridgehead carbons. My bridging carbons 1, 2, 3. So I have 3, and then I have 7 and 8. So that's 2, and then 1. So the one thing that I didn't mention before, and I'll mention it now, is that you actually have to go from largest number to the smallest number. Okay, so which means 3, 2, 1. Okay, and you put a dot in the middle of all of these, no commas, no dashes, a dot. Okay, that goes in the middle. So 3, 2, 1, not 1, 2, 3, not 2, 1, 3. Okay, 3, 2, 1, you go in the lower order. Okay, in there. So that's bicyclo 321 octane. So now I have a name for you, and we have to draw the structure, and I thought I'll just show you how to draw a structure for a bicyclic compound. So this one says it's a bicyclo 320 heptane. So it means I have a total of 7 carbons in there. All right, so here's what I do, because this is the easiest way to do this, and we love easy, don't we? Okay, so here we go. So I have heptane, and it's a bicyclic. So the first thing I do is I draw my bridgehead carbons. Okay, now in one bridge I have 3 carbons, so 3 carbons. Okay, that's not going very well, so let me try again over here. There, 3 carbons. So 1, 2, 3. Then I have 2 carbons. That's 2 carbons. And then the third bridge has no carbons. That's 0. And that's the structure. Okay, so you start from the bridgehead carbons, and then you join everything according to the number of carbons in the bridge. I hope that was easy enough. So what you should know from this little presentation is, of course, know that cycloalkenes, cycloalkanes are going to have the same kind of molecular formula. This will help you with constitutional isomers, okay, a little bit. Know where to start numbering, okay, which is alphabetical, all right? Know whether you should name the ring or the straight chain, and try to follow the rules as much as you can. But of course, if you can't, then there should be a good reason for why you're not following the rules, okay? And then of course you should know the nomenclature for bicyclic compounds.